This is the lesson for Chapter 5, Section 7, Scatter Plots and Trend Lines, Day 1. This is a big topic, I think pretty important because it uses what we learned about lines and coming up with equations of lines in a real-world situation. And so oftentimes we end up seeing situations that appear linear but are not exactly linear. And so what we have is what we call a scatter plot. And it's just basically a graph that relates two different sets of data unknowns along the x-axis and the y-axis. And then they display these ordered pairs, and they seem to have some sort of pattern. For instance, this one here has a relationship we call positive correlation because it appears as though it forms a line, or it looks to appear a line, but the points aren't all lined up there. But it does look as though as the x values increase, the y values increase, and that would be a positive correlation, just as this would be a positive slope. Where this one, it appears it has negative correlation because the y values are decreasing as the x values end up getting bigger. This one has no correlation. We don't see it going up or down in any way. And so what we can end up doing with this is predicting some data, predicting what outcomes could happen outside the values that we have, or maybe even inside the values we have. And so what we could do is draw what we call a trend line. And a trend line just goes in between the data, which ends up fitting, or kind of appearing to fit, that line, or where that line would end up being. However, there are lots of different ways you could end up drawing the trend line. I could have drawn it this way, I could have drawn it out this way, or even this way more. And so maybe not quite that far, but in this direction. So you can kind of see how trend lines, they're going to be about what the values are, but not always exact. Well, there is a trend line that is more exact, and they use some different techniques to come up with that value, and then we'll use the calculator to come up with that later on. We'll do that in the next lesson, but those are called lines of best fit, and those are a trend line that is the line that most predicts the data that we end up having. Well, from this we can either interpolate or extrapolate information to come up with predictions. Either interpolate in between values that are known, like a value here, I could find out what that value is, or extrapolate by coming up with values outside the region in which we have data points. And so we'll see that in the two examples that we end up having. So let's take a look at our first example, and here we have test scores. And so test scores are listed up here, and study time is down here. So the first thing to do is figure out, okay, well, what's the x value, what's the y value? So remember, our x values are going to end up representing independent values, or independent variable, and then our y value is going to end up being our dependent one. So basically what we're saying is that the y values need to depend on the x values, and that's what we see here. See, study time is going to be independent, but test scores are going to depend on how much time you end up studying. So we'll call the test scores the y values, and we'll call the study time the x values. And so we can start by at least coming up with our graph. And so we're going to do a scatter plot to start with. So we've got study time down here, and then we'll put down the units of time since they give it to us in minutes. And then we've got test scores here. So test scores. And then this is just going by 100% being the highest score. I guess these are percents here, so we'll maybe even write that in there, that we're dealing with percents. And when I look at this data, notice that I'm really high up on the data chart. I'm starting at 76 as my lowest amount, so I'm going to end up breaking this y-axis here, and maybe I'll call this one 60% right here. And let's see if I can fit them all in here. So if this is 70, 80, 90, 100, oh, easily. So maybe I can even go by twos. So we can call this one, instead of 70, we can call this one 65. So this would be like 70 here, and this would be 75, so this would be 80 right here. This would be 85, so 90 right here, and 100% right at the top. And then over on this side, I'll go study time. It looks like I'm going from 33 to 101. So one way you can figure out how far you should end up being is subtract the two values that you have. And then we'll end up doing a division problem as well. So let's go ahead and subtract those, so we'll just do 101 minus 33, and we get 68. And so from there I can count how many spaces I have. So it looks as though I have 10 spaces. So if I divide by 10, they give me about 6.8 spaces. Well, I'm not going to go 6.8, but I could end up going 7, or maybe just by 10s. 10's pretty close here, and I'm going to have a little extra, but that will end up working out, I think. So if I go by 10s, if I call this one 10, and this one 20, 30, 40, 50, 60, 70, 80, and 90, 100. So my data on the 101 minutes is going to be just a touch off, but pretty close. So I'll go ahead and plot some numbers that I have here. And so we've got our study time for our first one is for 33 minutes. We ended up getting a 76 on the test. So 33 minutes is just going to be just slightly off this line. And we got a 76 on the test. There's 75, so 76 is going to be right about here. And then we go over to 52 minutes. So there's 50, so 52 is a little off that line, and we go up to 85. So 85 is going to be right about here, right on this line, but we're at 52, so we're just a little off on the x-axis there. And then we go to 49 and 83. So 49 minutes is right around the 50 there, and 83 is going to be a little bit shy of that line, so it's about right there. And it's a little off the line, but that's okay. That's about where 49 is going to be. 101 minutes at 97. And then we had the 65 minutes, and there's 70, so 65 is right in the center, and we had a 92. And so that number would be about right in this region here. Alright, so once we have that, definitely I see how it's a positive correlation. So I can go ahead and draw the line through, and this is where having a ruler would be very handy. And freehanding it's not a good idea, but that's all I can do right now, so I'll do the best I can. So I've got a line that's going to come somewhere. And when I do this line, I want to try to get my line so that I have equal points on either side of the line. So it's going to look something like this when I draw that. I want to get some points below, some points above the line. So you have 2 points above, 3 points below. The difference between these points looks about the same. This one looks really close, and these two look okay. So that's about where it should end up being. So that's pretty close. And if I carried it down, it would come down somewhere in this range here. And so now I'm going to use some techniques to be able to find out what this line is. And so what I need to do is I need to select some points to represent where this line ends up crossing. And so I'm just going to pick some values. So let's say at about 40 minutes, it's about pretty close to maybe like 79. So I'm just going to pick this point right here. And so I'm going to say that, so first of all, before we get too far, let's go ahead and write down that we had positive correlation. Positive correlation as study time increases, we see that the test scores increase. So we did see that positive correlation. Because on the homework tonight they might ask us about that, so we need to write that in. Now we're going to work for our trend line. And so these can vary. So it depends on the points I end up picking. Otherwise, your line might be a little bit different than mine. So I see that my first point here, look, that I ended up picking is about, so I'll draw some squiggly lines there for about 40,79 is what I got there. And then I'll pick another point. Maybe at 65, it looks to be maybe about this point right there. Maybe we'll go 65,89. Let's say it is. So I picked these 2 points. And again, I'm just kind of arbitrary, just looking about what they are. And I take those 2 values, 65 and 89 there, and I'm going to go ahead and find out what that slope of this line is. And so I end up subtracting. So I do 89 minus 79, and then I do 65 minus 40. And so when I do that, this is going to give me the slope of the line, and so that gives me a 10 to 25, which is the same thing as 2 to 5. So I've got a 2 to 5 slope. So again, what this represents, the y value represented test scores, so percentage. So this means 2 percentage points increased by 2 percentage points. Let's go ahead and rewrite that. So it was an increase by 2 percentage points for every 5 minutes of studying. That's what the slope is telling me here. And so now what I want to do is I want to write an equation. So I'm going to use point slope, and I'm going to use y minus, and I'll use maybe this point right here. Y minus 79 equals my 2/5 times by x minus 40. And so I go ahead and do some work there. Y minus 79 equals 2/5 times, or 2/5 x. And then 5 goes into 40 8 times. 8 times 2 is 16. So minus 16. And so from that point, all I have to do is just add this 79 to both sides. Remember, they're opposite signs there, so I end up having to subtract those two numbers. So I end up with y equals 2/5 x and then plus 63. Alright, so there's my equation. So now what I could end up doing is I came up with my trend line. This trend line, this line that I drew here, is represented by this equation. And what does it mean? Well, let's go ahead and predict some data. And so I want to predict the grade for 10 minutes of studying. Okay, so if I study for 10 minutes, and so what I'm going to do is I'm going to take that 10 minutes and substitute it into my x value, because x represents time in which I study. So 10 minutes right there, and then add the 63. And when I go ahead and do that, 5 goes into 10 2 times, multiplying across, I get 4 plus 63. So that would be 67%. And so you can see a couple things here. Remember, our y-intercept would be 63%, so it looks like if I had 0 hours of studying, 63% would end up being my number. And it's a little bit off here. This is a little over 65%, but again, my line wasn't as straight as it could be. Using a ruler, you'd end up with a better line than what I have. So let's take a look at one more problem here. It says we have adult tickets and children's tickets, and we're comparing the two. So in this case is one in which typically, again, we're looking for what affects the other. Well, children's tickets are probably going to affect the adult tickets here. It looks like how many kids, you're probably going to have more adults with the higher number of children that end up attending. So I'm going to put children down here, and tickets, and then I'll put the adult tickets on the other side. Adult tickets, and we'll go ahead and come up with some numbers here. So maybe looking at my values, I'm going from 30 to 137. So if I subtract those two numbers, see, I'll end up with a 107. And so if I divide that by 10, that gives me 10.7. So I know I have to be higher than 10 in order to fit this, but it's just a little bit higher than 10. So fitting 100, and what I could end up doing is breaking this line and then sticking 30 at this point here. So that's one way of doing it. Or I could end up just going by higher numbers if I needed to. So I think I'll go ahead and start with some higher numbers, and so I'm going to go by 20s here. So let's say I call this one 20, 40, 60, 80, 90, and this was be 120 here, since I'm going by 40s, and this would be 160 right here. So I'm definitely have enough space there. This would be 140, and then over on this side, my adult tickets go from 10 to 50, so I don't need to have as much space on these. So maybe I'll just go by 10s here. So I'll call this one 20, 40, this one's 60, and so on. And I should have enough room on this in this case here. So 10 tickets and for adults and 30 children's tickets. So this would be 20 at this point, so 30 would be right in the center, and I have to go up to 10. So 10 is going to be right there. And then I have 55, so this is 60 here. So 50 is going to be right in the center, but then halfway in between would be about right here, and I have to go up to 20. So it's going to be about right there. And then I have 80, so 80 is right on this mark, and then I have to go up to 30, so 30 is going to be right there. And then 112, okay, so this is 100, 110 would be right in the center, so a little bit off to the right of center. And I go up to 40. And then the last one's 137. So this is 140. So 140, it's really close to 140, and it's up at 50, it looks like. So right about there. So this is definitely a positive correlation. So we have that once more. Positive correlation. And the reason it's that is as children's tickets increase, we end up seeing an increase in, as children's tickets increase, adult tickets increase. So now what we're going to do is we're going to draw the line through these points. And it's going to end up not ending. I don't need that line going down that way, so we'll just have it right there. And then I'm going to pick some values. So I look for where, again, if I had a ruler and I did this really straight, I would end up having that line a little bit right in between these values here. So this is not a good interpretation of that line. It's going to go more right in between these values like this. And so let me go ahead and try to draw that once more. See if I can get it any better than that. And so if I draw this again a little bit closer, it's going to end up going right in between these values. So you'll have some points above, some points below as you do this. And so I'm just going to pick some points. I try to look for where it crosses intervals, and then I kind of go with those. And so at 40, it looks like it crosses pretty close at 30. Not 30, but at 15. So it looks like it's crossing, going to end up being right about there. This point right there ends up being about 40, 15. And then I'll come up with one other point. How about 120? 120 looks like it crosses pretty close to the center there, and in between 40 and 50, so that would be 120, 45. So I'm just looking for some points where it might cross. This one would have been a good one too, but I know it was a little bit off because that was one of my exact points. So I try to find values that end up crossing or coming pretty close to crossing the interval marks, or in this case just ones that I look to be about right. And so that's where my line was. Those were values I picked. And so for my trend line, I'm going to find the slope using the 2 points I just found there. And so I go ahead and subtract. I've got 45 minus 15, and then down below that I got 120 minus 40. And so when I'm going to go ahead and subtract, I end up with 30 over 80, and that leaves me with 3/8. So what this means is for every 3 adults, there are 8 children, is what we end up saying in this case. So now I'm going to try to write an equation so I can predict it later on. So we go ahead and write y minus 15, and I'll use this point here, the 40, 15, equals then the 3/8 times by x minus 40. And I go ahead and distribute, and I've got y minus 15 equals 3/8 x minus 8 goes into 45 times by 3 makes 15. So when I go ahead and add the 15 to all sides, I end up getting y equals 3/8 x. And so it kind of makes sense. It looks like that line's going to go right through the origin when I go ahead and do that, so it looks pretty close. So now let's do some predictions. So let's predict the number of adults if 100 children tickets are sold. So this would be an interpolation because it's in between. It's something that we've got some data in between. The last one we had was extrapolation because we end up going outside the data range that we had. So all I'm going to do is just take that number, that equation, 3/8, and then multiply by 100. And so I end up getting y equals, and when I go ahead and do this work, we have 8 goes into 100, we have, well, we see 4 goes into this. This would be 25, this would be 2, so it would be 75 over 2, which would equal about 37.5. So we would just go ahead and maybe round this to about 38 adults. Is a pretty good approximation for where we're going to end up being there if 100 children were to attend. And so you could check by just going over to 100 and going up to that line and then straight across, and it looks about where it would be. 30 would be right here, 35, so 38 looks about right. So those are the types of problems we're going to see on tonight's homework. Good luck.